Hi to all. This e-content is about column chromatography. In this session, we are going to see column chromatography's introductions, history, definitions, principle and its classification, and their experimental technique and its requirement, and their applications, advantages and their disadvantages. Introduction. Chromatograph is a physical method of separation in which the component to be separated or distributed between two phases. One is stationary phase and another one is mobile phase. The stationary phase may be a solid or liquid supported on a solid or gel. May be a packed in a column, example column chromatography. Spread as a layer on glass or aluminum plate, example TLC, HPLC. Distributed as a liquid film, example GLC. The mobile phase may be a liquid, solvent or mixture of solvent or gases. History. The first chromatography column was developed by the Russian botanist Mikhail Svit in 1901, who washed an organic solution of plant pigment through a vertical glass column packed with an adsorbent material. He discovered that the pigment separated into a series of discrete colored bands on the column divided by regions entirely free of color. Column chromatography's definition. Column chromatograph is a separation technique in which the component of mixture is separated by using a glass column packed with stationary phase and the liquid mobile phase flowing continuously through the column. And it is experimental arrangement for column chromatography. First the solvent, second one is solution sample, third one is adsorbent, fourth one is bands developed by what are the bands developed by an elution. And its classification, column chromatography is separated into two categories depending on how the solvent flows down the column. First one is gravity column chromatography. If the solvent is allowed to flow down the column by gravity, it is called gravity column chromatography. And second one is flash chromatography. If the solvent is forced down the column by positive air pressure, it is called flash column chromatography, currently used in organic chemistry research laboratories. Principle. In column chromatography, the stationary phase is packed into glass or metal column. The mixture of sunlight is then applied and the mobile phase, commonly refers to as the eluent, it is passed through the column either by use of a pumping system or applied gas pressure. As the eluent flows through the column, the annual is separated on the basis of their distribution coefficient and emerge individually in the eluate as it leaves the column. Next one is experimental technique. This figure is about separation of sample components. A typical column chromatography system using a gas or liquid mobile phase consists of the following components. First one is stationary phase, chosen to be appropriate for the analyze to be separated, and the second one is column. In liquid chromatography, these are generally 25 to 50 centimeter long and 4 millimeter internal diameter and made up of stainless steel, whereas in gas chromatography they are 1 to 3 meter long and 2 to 4 millimeter internal diameter and made up of either glass or stainless steel. They may be either of the conventional type filled with stationary phase or of the microbore type in which the stationary phase is coated directly on the inside wall of the column. And next one is mobile phase and delivery system. Chosen to complement the stationary phase and hence to discriminate between the sample analyze and deliver a constant rate of flow into the column. And next one is injector system to deliver test sample to the top of the column in a reproducible manner. And next one is recorder and a chat recorder to give a continuous record of the presence of the analyte in the eluate as it emerges from the column. Reduction is usually based on the measurement of a physical parameter such as visible or ultraviolet absorption of fluorescence. A peak is chart recorder represents the each separated analyte. Next one is fractional collector for collecting the separated analytes for further biochemical studies. And next one is steps in column chromatography. Preparation of the column. The column mostly consists of glass tube packed with a suitable stationary phase. A glass, wool, cotton wool, or an adsorbate pad is placed at the bottom of the column before packing the stationary phase. After packing, a paper disc kept on the top so that the stationary layer is not distributed during the introduction of the sample or mobile phase. There are two types of preparing the column. First one is dry packing or dry filling. In this, the required quantity of adsorbent is poured as fine dry powder in the column and the solvent is allowed to flow through the column till equilibrium is reached. And second one is wet packing or wet filling. In this, the slurry of adsorbent with the mobile phase is prepared and is poured into the column. It is considered as the ideal technique for packing. Before using column, it should be washed properly and dried. The column should also be free from impurity and uniformly filled with the stationary phase. And next one is introduction of the sample. The sample, which is usually a mixture of component, is dissolved in minimum quantity of the mobile phase. The entire sample is introduced into the column at once and get adsorbed on the top position of the column. From this zone, individual sample can be separated by a process of elution. And next one is elution. By elution technique, the individual component are separated out from the column. It can be achieved by two techniques. One is isocratic elution technique. Same solvent composition or solvent of same polarity is used throughout the process of separation. Example, use of chloroform alone. And next one is gradient elution technique. Solvents of gradually increases, polarity increases, elutions then are used during the process of separation. Example, initial benzene, then chloroform, then ethyl acetate and then chloroform. Next one is reduction of component. If the compound separated in a column chromatography procedures are colored, the progress of the separation can simply be monitored visual. If the compounds to be isolated from column chromatography or colorless. In this case, small fraction of the elute is collected sequentially in labeled tubes and the composition of each fraction is analyzed by TLC. In this diagram, mixture to be separated as dissolved in the mobile phase, first one, and second mobile phase is added throughout the process, and third one the components, how the components are getting separated, and fourth one each component is collected as it reaches the bottom of the column. And their requirements: column, adsorbent, packing of column, wet packing, dry packing, solvent use, and what are the applications of the samples, identification, separation of component, recovery of components, and reduction of compound. And next one is applications. Column chromatography is used to isolate active ingredients. It is very helpful in separating compound mixtures. It is used to determine drug estimation from drug formulations. It is used to remove impurities and it is used to isolate metabolites from biological fluids. And next one is advantages. Any type of mixture can be separated by column chromatography. A quantity of the mixture can also be separated. Wider choose of mobile phase. In preparative type, the sample can be separated and reused, and their automation is possible. And the disadvantages is it takes more time to separate the compounds. Column chromatography has of low separation power relative to advanced separation technique. High quantities of solvent are essential, which is more expensive, and its automation makes more complex and costly. And these are the advantages of the column chromatography. Thank you.